Ladies, gentlemen, and other assorted organisms, welcome to Conics section. Today we will discuss ellipses. If you take a cone and you cut into it at an angle, the newly created surface will be an ellipse. When on a coordinate grid, an ellipse can either be vertical or horizontally stretched. These ellipse types can be graphed with an equation that differs depending on how it is stretched. The equation on the top represents the equation for an ellipse with a vertical stretch, whereas the equation on the bottom represents an ellipse with a horizontal stretch. Now, these equations may seem daunting, but A, B, H, and K are all constants. Also, A is greater than B, and they're both greater than 0. A, B, H, and K are all constants. X and Y are variables. H and K are the X and Y coordinates of the center of the ellipse. And the center requires you to find the lengths of the major and minor axes, 2A and 2B respectively. Since A is greater than B, the major axis is always longer than the minor axis. At the end of each axis is one of 4 vertices. Each vertex marks a change in direction if you follow the curve of the ellipse. On a horizontal ellipse, the vertices are at H plus or minus A, K, and at H, K plus or minus B. On a vertical ellipse, they are at H plus or minus B, K, and H, K plus or minus A. Finally, we come to the foci. Each ellipse has two foci which both lie on the major axis. They show where the ellipses curve, and the farther the foci apart from each other, the more dramatic the stretch of the ellipse is. To find where the foci are, we must first find C, which is the distance from the center to either focus, and is equal to the square root of A squared minus B squared. For a vertical ellipse, the foci are located at H, K plus or minus C, and on a horizontal ellipse, they are at H plus or minus C, K. If the foci are out of your ellipse, you have done something incredibly wrong. Try to find the square root of A squared minus B squared again, and make sure that A is greater than B. Thank you for watching.